Hello friends, I am Prafulla Pawar, faculty of Mechanical Engineering Department, and in this today's video we will see a point how to construct a parabola. So basically parabola can be constructed by two methods. First method is rectangle method and second method is eccentricity method, which is also called as directrix focus method. So in this today's video we will see how to construct a parabola by using a rectangle method. So as the name says, rectangle method, which means we have to construct a rectangle with the given dimensions and then we have to carry the construction in order to get the parabolic curve. Okay, so we'll see one problem statement and we will try to understand how to construct a parabola by using a rectangle method. So I will take a problem statement. Now the problem statement I will take is this. The problem statement will be given like this: construct a parabola by rectangle method if base is 150 mm and height is 100 mm. So there are two dimensions which are given. Base is given 150 mm and height is given 100 mm. So we have to construct a rectangle having base 150 mm and height 100 mm. So we'll try to construct the rectangle first. So I will draw a rectangle with the given dimensions, that is 150 and height is given as 100 mm. So with this we have constructed a rectangle with the dimensions which is given base 150 mm and height 100 mm. Now the next step is that we have to locate the midpoint of the base which is given 150 mm. So 150 mm means the midpoint will be located at 75 mm. So I will mark one point at a 75 mm distance and then I will draw one axis or one vertical line from that point. So I will draw one line passing through this point which is located at 75 mm. Now when I have drawn a line, I can see that this entire rectangle is getting divided into two equal parts. this rectangle which is having dimension of 75 by 100 and the other rectangle with the same dimensions, that is base 75 and height 100 mm. So I can see here is that the bigger rectangle of 150 by 100 is getting divided into two equal parts, 70 by 100, 75 by 100, 75 by 100. Now the next step is that we have to consider this half portion of rectangle which is having dimension 75 by 100 mm, and then we have to carry out the construction to locate the points in order to get the parabolic curve. Now to locate the point, we have to consider the horizontal part, that is the base and height of this smaller rectangle which is 75 by 100. Now I can see the dimension that it is 75 and height is 100. So I have to divide this 75 mm and 100 mm into equal number of divisions. Now equal number of divisions means what? This 75 mm, if I divide this 75 mm into 5 parts, then this 100 mm also I have to divide it into 5 parts. You can also go for 4 parts, you can also go for 6 parts, but the thing is that, or the condition is that, whatever the number of divisions I take for the horizontal side, I need to take the same number of divisions for the vertical side also. So as this is 75 mm, I can easily divide it into 5 parts, so each division will be equal to 15 mm. So I will try to divide it. This horizontal distance of 75 mm into 5 equal parts. So I will just mark points at 15 mm distance. So this is first point, this is second point, this is third point, fourth point. So I have located 4 points and 5 divisions for this 75 mm side. Each division is equal to 15 mm. So similarly, I need to divide this vertical side of this rectangle which is having dimension of 100 mm into 5 equal parts. Now that I can do it by distance of 20 mm, or each division will be equal to 20 mm. So I'll just adjust my scale here and I will locate the point at this point. This is first point, this is second point, this is third point, this is fourth point. So I have 4 points on each side of this rectangle having dimension of 75 by 100. Now for convenience, I'll just number these points on the horizontal side of the rectangle as well as vertical side of the rectangle. So I'll just give the numbers. So this point I will take it as 1 dash, this I will take it as 2 dash, 3 dash, 4 dash. And similarly on the vertical side I will name the numbers as 1, 1, then this is 2, 3 and this is 4. So I have 5 divisions of the vertical side, 5 divisions of the horizontal side. Now the thing is that I'll just name this rectangle for convenience. So I'll name this point as A point, this is B, this is C, this is D, and vertical axis I will take E and F. Now you can take any alphabetical order, A, B, C, D or P, Q, R, S, that is fine. Now what I have to do is, whatever number of divisions I have on the vertical side of the rectangle, I need to connect each point, that is 1, 2, 3 and 4 to the point which is E point here. So I'll just adjust the scale and I will connect points, or each points I will connect it to E point. So point number 1 on the vertical side I will connect it to E here. So point number 1 I will connect it to E point. Similarly point number 2 I will connect it to E point. Adjust the scale accordingly and I will connect it to E point here. Similarly point number 3, and point number 4 as well. Okay, so what we have done is we have drawn a rectangle with the given dimensions, that is 150 by 100 mm. Then we've divided this entire rectangle into two equal parts by drawing this EF line from the midpoint of 150 mm, that is 75 mm. Then we have considered this smaller rectangle having dimensions 75 by 100, and we have divided the horizontal side as well as vertical side into same number of divisions. So I have taken 5 divisions of 75 mm and 5 divisions of 100 mm. Then this vertical divisions what I have, or the numbers 1, 2, 3 and 4, all the numbers I have connected to point E here. Now we have to make use of the points which are available on this horizontal side of this rectangle, which is 1 dash, 2 dash, 3 dash and 4 dash. Now all we have to do is we have to adjust our scale parallel to side AD or parallel to side BC, which is nothing but vertical dimension. That is, I'll adjust the scale to So I'll just move my scale over this point number 1, and I'll just need to draw a vertical line from this point here. So I'll just select a color in order to easily identify the line. So I'll just draw a vertical line passing through point number 1 till it intersects line E1. So this will be my first point, and that point will be point number 1. So I will name it as P1 point. Similarly, I will just move my scale over point number 2 here, and I will draw a vertical line till it intersects line E2, and that will be the second point. So I will name that point. This will be the second point and point number P2. Similarly, I will move the scale now over to point number 3, and I will draw a vertical line till it intersects the line E3, and that will be the third point, and that point I will name it as P3. And point number 4, I will move the scale and I will draw a vertical line till it intersects line E4, and that will be the fourth point, that is, this will be point P4. So we have located point P1, P2, P3, P4, and when we connect from point number D, then P1, P2, P3, P4 and E, we will get the half profile of the parabola. Now the same construction we can also carry out in the other half of the rectangle, which is E, B, C and F, and there also we have to carry out the same procedure, which means we have to divide this horizontal side, that is FC, as well as CB into equal number of divisions, that is 5 number of divisions. So either we can do this thing, or we can just transfer these points on the other half of the rectangle by symmetry, because parabola is a symmetric curve. So we can just transfer the point on the other half of the rectangle. So what we will do is we'll just divide this side, that is FC, into same number of divisions again. That is 5 divisions. So I'll move the scale here. So 15 mm each division it will have. So this is first point, this is second point, third, fourth and fifth point will be, or it will have 5 divisions. Similarly, I will just rotate this scale now again. So I'll just move the scale here, and I'll divide this rectangle into 5 vertical side of the rectangle into 5 divisions. Each division will be equal to 20 mm. So I'll use the same numbering here again. So this will be point 1 dash, 2 dash, 3 dash and 4 dash. Similarly, I will use the numbers here as 1, 2, 3 and 4. Okay, now the same procedure I need to carry out. I need to connect the vertical side points which are there 1, 2, 3 and 4 to the E point, and then I have to draw the vertical lines passing from 1 dash, 2 dash, 3 dash and 4 dash till it intersects the respective line, that is E1, E2, E3 and E4. So we'll just connect the line, these points first. We'll try to connect this E point to point number 1. Similarly, we'll connect it to point number 2. We'll connect it to point number 3. And we'll connect it to point number 4. Now we'll move our scale to point number 1 dash here and draw a vertical line passing through point 1 dash till it intersects the first line, that is E1. Then we'll draw a line passing through point number 2 dash, then we'll passing through point number 3 dash, and then last passing through point number 4 dash. So respective points we will get it. So this is the point, this is also a point, this is also a point, intersection of 1 dash to E1, 2 dash to E2, 3 dash to E3, 4 dash to E4. So these are the points. So I'll just continue the numbering. So this is P5, this is P6, P7 and P8. So we have got the points starting from P1, P2, P3, P4, P5, P6, P7, P8. Now we just need to connect these points starting from D, then P1, P2, P3, P4, E, then P5, P6, P7, P8 and C. So when we connect these points, we'll get a parabolic profile. So we'll just connect it and we'll see how the profile will look. So I'll just connect the dots, that is D, P1, P2, P3, P4 and E point. And similarly, we will go to P5, P6, P7, P8 and C. So this profile what we have got starting from D, P1, P2, P3, P4, E, P5, P6, P7, P8 and C. This profile is nothing but a parabola which we have constructed using a rectangle method, and the dimensions of the rectangle are given as 150 mm is the base of the rectangle and 100 mm is the height of rectangle. So thank you.